Today's presenter is Senior Validation Engineer Dave Kugler of Geisel Software. Dave's unique expertise in electrical system design, software engineering, communication systems architecture, and real-time software development positions him as a preeminent expert in the field of prototype validation. His real-world experience includes long tenures at notable computing technology firms and the completion of 36 integrated circuit products. And without further ado, I'll give the stage to our presenter, Dave Kugler.
Post-design validation is the last step in the engineering process. It controls when a design moves from the prototype stage into the manufacturing stage. It's the first time that the prototype's got to run in the real world and is subject to all sorts of real-world phenomena. It's the best time to catch design faults before they reach the customer. This is a critical step. It's a critical step in every company. It controls cash flow. Any delay or upset in the validation process means the prototype's going to be late getting into manufacturing and product's going to be late getting to customers. Therefore, you aren't going to get paid. So, getting validation to work as quickly and as efficiently as possible is critical. Let's start with a little story. You're working for a small startup. You're the engineering manager, and you have spent the last 18 months working on producing the design for your new application-specific integrated circuit. You have gone through hours and hours of simulation, design walkthroughs, verification, troubleshooting sessions, writing specs, a whole bunch of work. But now you've reached that magical point where the design is ready. You have put all the pieces together, you've closed timing, and you've met all the design rules, and now you've sent it off to manufacturing. You're at the tape-out stage. In a few months, or a few weeks, or a few months, you're going to have this chip coming back. At this point in time, everybody's pretty happy, and you throw a party. So people are dancing, singing, playing games, high-fiving everybody, and right in the middle of the party, while you're feeling nice and proud, somebody just comes over you and asks an innocent question. Who's going to bring up the device? What? Who's going to bring up the device? And you turn to your board designer, and your board designer kind of shakes his head and says, yeah, I can sort of get the board to start and a few other things to run, but I don't know how to program this thing, and I certainly don't know how to test it all. You look at your design engineers. Your design engineers say, don't look at us. We just design this thing. We don't do hardware. We haven't touched a real live system in years, let alone try to program this thing. We don't know anything about programming. You look at your software guys, and they're looking back at you and saying, it's not us, guy. We only work when the hardware works. We don't know how to handle it when the hardware is malfunctioning, and we're not really good at all that that low-level stuff. That's always done for us. Oops! Now you've hit a big problem. Who is going to do this work? You frantically start looking at your Rolodex. You start looking at your contacts. You start calling up your friends, anybody in the business, and asking around, say, who has got people that can do this? If you're lucky, maybe you'll find a consulting house that has a couple people that are available that can do validation work. But it might be a hard find, and then you're going to discover they're kind of scarce to come by. So you don't want to be that manager. You don't want to be the guy that's at the end of the project, that's near at the end of the project, and you can't close the final gap because you weren't prepared. Think this doesn't happen? I've been working with at least 3 companies over my career that this is exactly the scenario that they fell into. I was hired as a consultant to deal with these issues, to be the validation engineer, to bring the systems to life. this guy. No, 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 no. You don't want to be this person. You want to anticipate what you're going to need and be well prepared before you get there. The point of this discussion will be give you some insight into what you're up against and how you will find people that can fill this role. So let's just talk a bit now about post-silicon, post-design validation and how it might differ from other activities in the company. The closest thing that comes to most people associate quality assurance, manufacturing quality assurance. Well, validation's point in life is to examine all aspects of the design seen through the prototype to make sure that everything works as intended. This is a deep dive, a deep exploration of the design. Manufacturing QA is much more interested in a particular device that has been built that actually works as expected. They're not going to do a deep dive through all of the engineering possibilities. They just want a quick goodness test so that they can ship the product. Very different focus, very different worlds. Validation, much of what's done in validation will be fed through to manufacturing QA to drive some of their processes and scripts, but QA is not going to do the validation's job for it. Some of the things that differ between the two. Most prototype boards have extra features put on them. Test points, they might have a set of LEDs, there might be a specialized signal contact like an SMA connector. It might even have some extra hardware on the board, and we might use things like variable voltage supplies instead of a fixed voltage supply. Things that will not go into the final product and will probably be removed from manufacturing. And oh, by the way, all these extra little things tend to cost money, so they tend to get bounced off the final product anyway. A product, as manufactured, is fixed. You're not going to be changing it, or you're not going to be changing it fairly rapidly. Anything that's done on a manufactured product costs a lot to revise. So you want to do all your changes up front and in the prototype. Again, when you're doing the validation effort, this is the time to find these issues. Validation is a one-off. It only occurs once at the tail end of design process, and everything that's done will be fed forward to other people. QA, for example, it might be fed to the field force, might be fed to marketing, and so on and so forth. QA tests deal with large volumes, large data. Verification, validation, you never have more than a handful of devices. And the level of testing that you're applying to them takes a long time, so you really don't get the volume data. You actually need both together in order to come up with a viable real-world product. What's a validation engineer? Well, a validation engineer is going to be working from the customer's perspective. In fact, they're representative of the customer. They will only be dealing with customer-facing material, the data sheet, the user manual, the design guides, the reference designs, or everything that the customer would see. That is the material you use. You can't cheat. You cannot go back and look at the interior design documents at the interior. You can't refer to the engineering efforts unless you're going to be taking that information and then feeding it into the material. Half of the validation effort is dealing with the product at hand. The other half is dealing with the customer material, making sure that everything is complete and proper. Your validation engineer, unfortunately, has to be accomplished in several areas. Obviously, if you have a board, a digital or an analog components on those boards, you have to understand the electronics. You have to be able to at least know the language that the designers are speaking in. You have to be able to understand how these interfaces work and how they might fail. You also need to be very proficient in computer software. You're going to be writing a lot of it. You're going to be writing a lot of it very quickly. It doesn't have to be as highly engineered, say, as your end user software, but it's going to be significant volume, and you'll be generating it on demand very quickly as you discover problems. You will also might have to have some ability to deal with mechanics, the electromechanical device. If you're doing a robot arm, for example, you've got to understand all that terminology. You've got to understand the limits of a mechanical system. If you're doing biomedical devices, again, now there's a whole nother domain series of languages that you have to learn. So this is one of the things that makes it difficult. Proficient at software, proficient at engineering concurrently. All right, let's talk about small companies. Validation is a transient activity, truly. You might only work 3 or 6 months out of an 18-month design cycle. This kind of poses a challenge for a small firm because you're going to have a few high-priced engineers sitting around not doing very much for several months, weeks or months at a time. There's a strong tendency to try to take whatever validation resources you have and reassign it to design activities, and then maybe borrow it back when it comes time for validation. You will find that, once someone starts to do design, they probably don't want to come back and do a lot of validation. Kind of a rare person. But these are the economics you have to deal with. So you're going to be hiring staff, and you have to be careful that the staff might want to migrate around. A few more details about validation. You are looking for defects in a product design. So basically, this is very much a quality function. You have to be willing to dive into a design, look in the non-obvious places to try to find things that might come back to bite you. The last thing you want in the world is have a customer come back with a bug report from the field that renders your whole device useless, or the customer wants their money back. So that's what you're after, design defects. There are skills that you require for digging in and troubleshooting. In fact, 90% of what you're going to be dealing with is troubleshooting, either in the electrical space, the analog space, the software itself that you're trying to write, external test equipment you might be using, a variety of places where tests can go awry. So you need people that aren't flustered by having an environment that's a little unstable, and you have to continually go and keep track of everything. Be very careful with how you work. Validators need to be skeptical. Most importantly, they need to be skeptical of their own work, because most of the time the error is in your software. Other times you might find that it's errors in your understanding of how the hardware is going to work. And on occasion you will hit the situation where the error happens to be the design itself. All right, so you're trying to now find kind of a rare combination of people. They got great skills. They can do design work. They can write software. They are generally very, very good. They will know the design as well, if not better than most of the designers. So there's this terrible tendency that even you get someone in a validation role that they want to go into design or get pulled into design and don't come back. So the other thing that you need people that don't give up on the first problem, that keep on digging. It may take months, for example, to get a given piece of hardware to work. Lots of tests, lots of software, lots of brainstorming, but you just can't give up. Certainly not on the first few tries when they fail. So tenacity, stubbornness, in fact, is a good habit to have. All right, you got two roles. You can hire people from the outside. It's hard to write a good job description. It's hard to identify the people with the correct set of skills, especially if they haven't done this kind of work directly, but only indirectly. You might have better luck if you go outsourcing. Some of the consulting shops do have people on staff that have done this kind of work and are available. As I've said myself, this is how I got into the game. I was outsourced, and I came in on several companies and drove their validation efforts. A couple things to note with the outside resources: they can bring in a very fresh perspective, something that you don't necessarily have. They have seen other people and how they've done things, and let's hope that they're creative and you'll look at your problems and try to work out schemes that work well for you and your environment. So, some key insights on this to wrap things up. Validation is a strategic necessity. You can't get by without it. Somebody has got to turn the machine on. Someone's got to do all the initial programming. And someone's got to make sure that the device really does work and meets the customer's needs. These people, as we've mentioned before, are a scarce resource. If you find one, you want to hold on to that engineer. You want to keep them interested in doing validation work. You also may want to be looking around your own staff and trying to develop the skill sets among your own staff. The choice between internal versus external, of course, comes down to economic efficiency. How much money can I spend on an external contractor? It might be expensive versus taking someone that I already have on staff and trying to coerce them into working as a validator instead of a designer. An interesting trade-off and an interesting management opportunity. Finally, quality and objectivity can't be forgotten. You need a team. Your validators, you need to be honest, sort of like officials in a basketball or football game. They play the rules. They observe the game. They judge based upon the rules as they stand in the book and give you an objective feedback. Same thing with your validation folks. They are agitating. They're judging your design and trying to make sure that everything has been tested and is either known to work or needs improvement. Thank you very much for listening. We will be available to answer questions and hope to keep you up to date on the latest in validation.
Thank you, Dave, for that detailed and informative presentation. And thank you to everyone who sent in Q&A submissions. We'll answer those questions now. So, Dave, the first question is, how do you define the validation plan and what drives this process?
Complicated answer. Basically, it gets down to how good is your customer-facing documentation. For instance, if you have a data sheet and the data sheet describes all the features of the chip, all the operating units, describes, say, the register set, then you've got a good place to start. You can walk through that sheet, and then what I do is I come up with a line item for each thing that I see. I'll write down a specific test. So at the end of the day, if it's a big device, I'm going to have a lot of tests. I will go through and try to sort those into basically things that are essential, that have to work. Those tests must be done. There are the nominal ones, the ones that should work, that a customer probably would expect. But if one or two of them fail, it's not going to kill the design. And then finally, I have the nice to haves. Yeah, the designer put in a few extra things to allow you to debug and troubleshoot the system. It'd be nice if they worked, but it's not going to kill me if it doesn't. And probably the only person who would ever notice would be those people trying to debug the system. There are other things that also enter in. If you have a device that has a variety of electrical interfaces, there may be standards that you have to check against. For example, PCI interface. Yes, there is a compliance suite. There is a series of the pieces of test equipment that you can procure to exercise your device to make sure that, yes, it meets the PCI standard. It will work in a system. I probably need to run it in several systems. So that is, again, another way of building up a test plan. Finally, there are usually what we'll call characterization measurements that you have to do. Operate the device over temperature, operate the device over voltage range, drop it on the floor a few times. That sort of thing gets added in. So at the end of the day, you'll end up with a fairly large plan, and you'll discover something. You can always come up with more tests than you have time to execute. So filtering out the plan to determine what you must do and what you have time to do. And then, there are things you're going to leave behind. It's a long process. We have a whole seminar on just how to write up a test plan.
Great. Dave, next question. Could you give some details on selecting test equipment and how it fits into the validation plan.
Test equipment. Sort of like your prototype board that you're using, test equipment extends your ability to look into the design, your ability to control the design. Take PCI, for instance. It's very difficult to troubleshoot a PCI situation if you don't have a PCI analyzer. So what the analyzer is going to do is going to watch the traffic between your host machine and your target system, and you can see in detail what's going on. Perhaps the issue is your device drivers are working. It's writing to the wrong address. You may never, ever see that unless you've got some piece of equipment that will show you the logic trace. Anytime I can get a direct observation or get direct measurement, it greatly helps me when I'm trying to troubleshoot a system. It makes the fault analysis a lot simpler. So there's a catch, though. Test equipment's expensive. You'll probably end up having to rent it. Typically, high-end oscopes for high-speed Ethernet, for example, can run you up to $600K to purchase. And a rental rate's about 10% of that, so you're looking at $60K a month. The other thing to consider, test equipment is difficult to use. They're very capable, but it takes a while to become familiar with it. A lot of people, when they're renting equipment, want to show up on the day the device is showing up. Nobody's had any chance to get familiar with it, so you're trying to do things undercover, under duress. That's not a good situation. So when I'm looking at test equipment, I want to know what I can get, and I would like to get it at least a month before my boards arrive. And whatever time I think I'm going to need it for, probably I need to double that. It is having a good piece of test equipment around can save you oodles and oodles of human time.
And Dave, we'll have time for one last question, and one that came over is, where do you find people with validation skills?
Well, one of my best validation engineers actually came from WPI's game programming program. Game programmers are somewhat unique in the sense that they have a good idea of time and behavior. They're doing stuff in real time. All electrical systems are real time, so getting that time behavior down is important. Whereas a classical software engineer might not see timing behavior for a good long time. We try searching, obviously, in like the embedded software space. Usually those folks are again, doing a lot of low-level physical programming. They are good candidates. But it gets thin beyond that. So if I just go out and write and go to the general website, just go to a general job site and start to make a request, I'm amazed at some of the replies that I get back. A lot of people have a different interpretation of the word validation than what we mean here in this sense. You'll end up with a lot of medical people who are proving drug protocols are working. So it can be a real challenge. And so the scarcity aspect is probably the most difficult one to solve.
Dave, thank you. And thank you to all the audience members for tuning in. Also, feel free to connect with us on social media if you haven't already, and stay tuned for announcements of upcoming free masterclasses.